Okay, so I want to explain the last two that I didn't in the last video, the two that we did today. First, let me tell you, one of these, and it's going to be this one and this very last one. One of these, there's two symbols you need to know. This is like a line on paper, because I want to show you one's capital and one's lowercase. This is a capital P. There is no vector arrow because this is in fact a scalar quantity, and that's power. And actually we're going to be looking for two equations on this one. Okay, there's more, and there's other ways you can do this. Anyway, that says power. It's annoying me. Okay, and then this one's a lowercase p with a vector arrow, and this one's momentum. Now, I want you to think of somebody who's powerful. Why would somebody say a lawyer, somebody who makes a lot of money? Not even a lawyer, just somebody who makes a lot of money. Donald Trump. God. Anyway, why would Donald Trump be more powerful than somebody who works in McDonald's? Basically because he makes more money and he can make more money, which money's power. Money's, he can get more work done, I guess. That's why they pay him more or whatever. But, basically he can get things done quickly and influence things quickly and move energy around quickly. And momentum, you might have heard, like that team's got a lot of momentum, or you need to get some momentum, get the ball rolling. Think about kind of those things with momentum and power. I'll come back to that. Let's look at the easy one first. Remember, meters, kilograms, seconds, or this would be your length. Yeah, your kilograms remembers mass, and then seconds measures time. So let's look at this. Kilograms, I'm going to take this and I'm going to bring this over here, and now this is apples, remember. Hopefully this looks red, the ink that I'm using. So kilograms, and that is, I'm going to write the M for mass, not for meters. Mass orange measured in, or mass red, or apples measured in this orange over here, which is kilograms. Okay, and see, look, if so, we get rid of the kilograms, and what are you left with? Meters per second. What's that? That's your velocity. I guess it could be speed, but I'm going to go ahead and tell you this is velocity. When in doubt, assume it's velocity in physics. Assume it has a direction. Okay, well, think about it. Does that sound more like Donald Trump getting things done quickly, allegedly, or getting the ball rolling? Hopefully it sounds like get the ball rolling, because this is momentum. Way to think about that. I'll give you an example. Would you rather get hit in the head with a marble or a bowling ball? Hopefully you wanted to know more information, because suppose I said the bowling ball was barely thrown at you, but the marble was fired out of a gun. So the velocity matters. And the reason why that's not speed, why that's velocity and not speed, because if the gun weren't pointed at you, you wouldn't be as concerned. So you care about what direction and how fast and how big. See, these are directly proportional. Okay, so that takes care of momentum. Now let's look at this other one, which we know is power, but let's look at the equation. I'm going to go over here. I'll write P, capital P for power, and you know it's going to be a scalar. There's two. Let's look at the first one. Let's just do what we did here. So kilogram right here, that would be your mass, right? So meters squared over seconds cubed. That's not anything, but can you pull one of these out? I'd say go with this. It clearly has both of these things. So we'll just take 1 meter. I'll just kind of pretend scratch out that squared. Okay. Well, here, let me write it over here actually. Kilogram meters squared over seconds cubed. So here's our mass. I'm going to scratch that out. Okay, and then let's go ahead and do acceleration next to that. Okay, acceleration is meters and then seconds squared. So that would just leave us with meters to the first and seconds to the, took away 2 of the seconds. Because remember, meters squared is just like meters, and seconds cubed is like seconds. So anyway, I scratched one of them out up here, 2 of them out down here, and that's meters per second. So this would be velocity. I guess acceleration has an arrow. But you know what? This is kind of weird, but this has, what is mass times acceleration? Kilogram, what would that be? Kilogram meter per second squared. Hey, that's force. Therefore, power equals force. And I'm just going to go ahead and tell you, when we start really working with this, you'll get it. This is a dot product. Cosine theta. Power is force. Why doesn't that want to stay? Force dot velocity. Force, seriously, force cosine of velocity. Okay, now there's another way to write this one. Let's look at it again. Let's scratch that out. I'm going to write the units. Kilogram meter squared over seconds cubed. So instead of like looking for mass, I'm going to see if I can find a chunk up here. Well, we already used force, which makes sense. Yeah, you can probably kind of see how force and then times velocity. What about work? Is that in here? Do I have a kilogram meter squared over second squared? I sure do. So let's go, this is power. And you can do this as change in energy. I'm going to go ahead and tell you it's work, but I would totally accept change in energy. But let's just go ahead and go with work. So you have kilogram meter over second squared, right? So kilogram meter, let's just do the top. Kilogram goes away. All right, W for work up here. Kilogram goes away, meters per second goes away. And down here, 2 of your seconds, not all 3 go away. So you're left with just the seconds in your denominator. And what's measured in seconds? Time. So that's your other one for power. And that's a watt. See, J.J. Watt's very powerful in the defense. Too bad about the offense, but whatever.